Here's a follow-up to our video on the yellow birds. We're going to call it the yellow birds in topology. And just for review, in our original video we found out that there's the same number of points on this red line segment as there are on this blue line segment. And that was a little counterintuitive for most of us because I know that the blue line is longer than the red line. But it turns out talking about the number of points on a line and talking about the distance between points on a line are actually two different topics. To talk about the distance between points on a line, you have to associate a metric with the line. That is, you have to associate numbers with it. Now, there's a branch of mathematics called topology where you don't do this. You just take away the metric completely and only look at the points on a line and the way in which they line up. So in topology, these three figures right here are exactly the same. They're all simple closed curves. And what they do is they divide the space they're in up into an inside and an outside. And you can't go from one to the other without crossing the simple closed curves. Each of these curves is not a simple closed curve because I can go from what looks like the inside to the outside by just going through that hole right there. But these three curves do have something else in common. They have a first point and a last point, which you can arbitrarily assign. But if this is the first point, then I can travel along this curve and look at all the points in the order that they appear until I get to the last point. Same thing with this curve, start here, go around all the points till you end up at the last point. But these curves here do not divide the space up into an inside and an outside like a simple closed curve does. So you might say, well, what has this got to do with me or real life? Well, I like this idea of a simple closed curve as a good model for what happens as babies progress in life. If you look at little babies when they're born, they can't tell the difference between themselves and everything else. They think it's all them. And as they age a little bit, they start to draw this boundary in where inside is them and outside is everything else. And it's kind of fun to watch little babies when they first discover their ears. They'll be holding onto their ears, really concentrating on them. And I like to think that they're trying to decide, hey, is that ear inside or outside? Is that part of me or is that part of everything else? So for me, that simple closed curve is a good model for how babies progress in life as they see the difference between them and everything else. I think it's also a good model for consciousness in a way. When our consciousness is focused on ourselves, we're inside here just focused on us. We can't notice anything else. When we're only focused on ourselves, there is no boundary right here. But for us to go out and focus on something else around the world, we have to have created this boundary, the boundary between me and, let's say, you or the outside world. So we go back and forth between these two places many times during the day, so we create and recreate this little boundary like this, which to me has the same properties as a simple closed curve. So for me, I understand things in real life sometimes a lot better when I think of them in terms of these mathematical concepts. And in particular, I like this branch of mathematics called topology, and in particular, I really like simple closed curves. Really easy idea here. The simple closed curve just divides the space up into an inside and an outside that you can't get from one to the other without crossing that simple closed curve. So there's a look at our video on the yellow birds and topology.